Hello, 5th graders. My name is Teacher Fritzi, and today's lesson is a nanoscale view of condensation. And today's question of the day is, what happens at the nanoscale when raindrops form? Now, we all come across water, whether that's to brush your teeth, to cook with, when boiling pasta, or most importantly, when we drink water. But we don't always know what is happening at the nanoscale, do we? We use water as an important source of living, yet why does water harden when it's colder? Why does it evaporate? Or how do the molecules look when the water evaporates? Why does it condense? There's all these questions that hopefully I will be able to answer for you guys today. The lesson is 2.3. Once again, a nanoscale view of condensation, and essentially I would have the PowerPoint up here. Activity 1. Reading about phases of water. What did we learn when we observed a cup of ice water in a plastic bag and where the water drops come from? From investigation 2. Why did water vapor condense on cups in our investigations? Now, some students may respond, water drops come from water vapor in the air, or because the cups were cold. From our investigations, we know that water drops from on the cup when water vapor in the air gets cold and condenses from gas to liquid. Remember that we are investigating the question, how do raindrops form? Today we will continue investigating how raindrops form by zooming in to see what happens to water vapor when it condenses into liquid form. We will first start our investigation on our question by reading a section of Water Encyclopedia. And this is where I would distribute a copy of the Water Encyclopedia as well as a packet of the questions that we will be doing. We are going to first open up our pages to pages 20, 21 in our notebooks. We will read 28 and 29 in Water Encyclopedia. And while reading, you guys are going to be recording and drawing in your notebooks to show what you have learned. Okay, and then your packet is going to look like this. So this is going to be the first page that you guys are required to fill out. Following that will be this one. Now, I recommend that you first read through pages 28 to 29, and then I would recommend that you guys first maybe draw the nanoscale view of the water, and then go back to page 20 and answer the questions. I feel like putting a visual first will really help you describe what is happening. So I'll give you guys a couple minutes to answer the questions. And then at this point, I'll be walking around the table. I would be circulating, making sure that the students are reading, recording, and drawing. I will encourage students to talk with their partners as they complete the notebook page. So I'm allowing students, for their given time, I'd probably give them about 5 minutes. And once you guys are done filling both pages out, please raise your hand so that I know that you guys are all done. Okay, can I go ahead and get a couple people to share their answers and to share their pictures? And this is where we will go around the table. I'll give everybody a chance to answer both questions, to show their peers the drawings that they made. And once that's done, we'd circulate around to have a whole group discussion at the very end, making sure that everybody's on the same page. So the first question is, describe water molecules when they are in water vapor. So molecules are far apart in water vapor and close together in liquid water, which is the following question. When the temperature is colder when molecules are in the liquid phase and warmer when molecules are in the water phase. So this is actually a picture of what the water molecules look like when they are water vapor. And as you can see here, it says that it is warm. Now, when that condenses, this is how liquid water looks like. And you can see here the temperature is cold. So the difference can be seen here, especially with the molecules, they're more dense. So that's to answer both questions 1 and 2. And then as for the nanoscale view for the image on the side of the cup, this is what your image should look like. So here we have liquid water inside the cup. As you can see, the water is more condensed. And as that water evaporates, the water vapor outside the cup is more spread apart rather than stuck together. And this is water that condensed on the cup itself. So you can see that when it's on the cup, it's still fairly condensed. But then once the water has evaporated or the water vapor is outside the cup, we can see that the molecules are more spread apart. Great, good job, guys. We'll go ahead and now turn to page 25 in our water encyclopedia. And we will be reading this passage right here. I just want to make sure that you guys are all on the same page. This is what it should look like. And I will have one of you guys read the first paragraph. This is where I pick a student to read the first paragraph. Once they've read that, I'll read the following paragraph. Though we can't see individual water molecules, we can see groups of water molecules when there are enough of them and they are close together. Imagine a speck of dust on the floor. You may not be able to see one speck by itself. However, if you sweep the floor, you gather all the dust that was spread out across the floor and end up with a pile you can see, collect, and throw away. In the image here, this is a water droplet that contains trillions of water molecules like the one shown here in zoomed in form. These water molecules are represented with red and white circles. And this is where we'll also take down the vocabulary, which our vocabulary for today is molecule, which is a group of atoms joined together in a particular way. Okay. We can observe the water drop, but the molecules are at the nanoscale. What ideas do you have about what the nanoscale is? So remember, this is the nanoscale. What ideas do you guys have about what that is in words? I'll pick out a couple students here at their answer. From now on, we'll be thinking about what is happening at the observable scale, which we can see, and what is happening with molecules at the nanoscale, which is too small to observe directly. Activity 2, exploring the Earth system simulation. What do you think happens to water molecules when water vapor condenses into raindrops in the atmosphere? I'll give you guys a couple minutes to discuss with your partners. And this is just something that we won't quite answer yet, that we are hopefully to find an answer later. So go ahead and turn to your partners and discuss, what do you think happens to water molecules when water vapor condenses into raindrops in the atmosphere?